to ask this, what did you do yesterday? We're trying to recall some kind of memory, right? And then, based on the response, and we're trying to, we know the distribution there is pretty clear, and we want to know something here. And then, it's, based on our training, we know that maybe we should ask this question instead. So we're trying to ask a couple of questions, and then, we kind of have this kind of very kind of good distribution approximated. And then, the technical details is that, the user simulator is basically, we have the question encodings in this work. So we basically use fixed amount of questions as 104 and 110, can't remember, but we have this kind of questions as an action. And then the simulator will be built in a way where the output of the simulator will be the scaptar embeddings of that. So this is a simulator, right? So outside simulator, we have this MCI classifiers where we're trying to predict, right? Trying to predict based on the existing conversation what is confidence of our classifier, and then with all this kind of states, what we're trying to do, the reinforcement learning agent is trying to engage with the dialogue manager, trying to ask new questions, right? So and then trying to improve the classifier confidence, right? So one of the goals is, and we're trying to ask question in a way that I can boost the confidence of my classifier as much as possible. So that's how we do. And then we find out, by using this this model, is we actually we trying to so it's resumed, but so we find out that with just a couple of questions, we can do pretty good distribution as compared to the full conversation, fully engaged conversation. And then so that's work we published last year, and then we find out with this kind of method, right? So we are able to identify this MCI with even higher performance, right? So recall the number we had was 73, and then now we have this 81.8. So it's kind of amazing. I would say there's a lot of information in the language, and then recall that the distribution is it's pretty it's pretty, I would say. It's pretty early stage, and there are a lot of improvements we can do. And then, by doing this, we can do more efficient because we don't have to conduct like a long conversation with a patient. And then we can, on the other hand, unexpectedly have higher performance, right? And then if you kind of think about what's going on, so we used to have this kind of supervised learning where we use a simple model to collect the distribution, and then we'll reformulate that into a reinforcement learning. And then this reinforcement learning actually is, it's a reformulation of the supervised learning where it's trying to, dig into the conversation and trying to look into some key information and then discuss some of the information. For those of you who are coming from supervised learning as my background, you'll realize that this is perhaps trying to do some kind of information cleaning, or you can think, in broader cases, doing some kind of I'll say feature selection type of thing, right? So you're trying to do. I was aware that more recently people are using reinforcement learning in a lot of interesting different learning to do some kind of feature selection and things like that. I would say they may have the very similar spirit underlying. And then I'll talk about. I'll spend 2 minutes on the future work, right? So we recently get the 4 million grant by collaborating with, our collaboration actually lead to this R1. So we can continue working on this in the next 5 years, where we're trying to work on more high efficiency language markers. Now we only use this very simple embeddings, and we may have to customize the embedding and customize a language model for this. And then and also we're trying to build an app on that. So, the privacy issues and the robustness issue could be an issue, right? So because we're training the model in a lab experiment, so we have very good device and, very clear conversation. But in the end, if you want to deploy that to somebody who's holding a phone, maybe it's pretty, the environment is pretty awful by then, right? So you have to hard way to actually run your algorithm on that kind of scenario. Right. And then moreover, we're trying to generate these new questions instead of sticking to those 100 questions we had before. So it's more like a kind of goal-oriented chit chat. And then, yeah, so we're trying to bring, because we have, in addition to the language, we also have this video captured. So, the facial expressions, right? Sometimes when I ask you about your, let's say your short-term memory, trying to invoke your short-term memory, and if you had a problem doing that, your face will show something. We're trying to extract that kind of thing as well. You're trying to use more and more information inside the language to do that. More robust multimodality learning. And then, yeah, so as I just said, this robustness is a kind of issue when you're trying to deploy your model, and if you're trying to do this online learning, and then you kind of, it's you kind of have this problem when you're trying to deploy an app, right? Some people will use very good phone, and sometimes people won't use very good phone or device. And then, if you're trying to train something, it's going to be not, some of them can use robustness kind of augmented algorithms, using the adversarial training and advanced smoothing, but some of them won't be able to have a resource to do that. But can we kind of share, kind of transfer this kind of robustness, not just performance, but robustness to other people? So that's something we're working on as well. Yeah, so, and the other thing is that we kind of funded this kind of nonprofit organization where we're trying to offer this technology to, the seniors. At the moment, we're trying to do that in the United States. We're trying to, we're trying to build this mechanism where we recruit those subjects, and we're trying to give them, the app, and then give them the, some of the conversation, so to help them. Yeah, so trying to push this technology all the way to the subjects. Yeah, so that's a brief introduction of our work recently. So we'll work on this kind of convergent AI in our lab, and then yeah, so I would like to thank our collaborators and my students. So brilliant students are the ones who are actually getting most hard work done here. So thank you so much. And then now I'll say question time, or Faye is going to ask me some questions.
Yeah, thank you, Jiayu, for the nice presentation, and for the folks on the online. So I have been collaborating with Jiayu in the past almost 10 years, and of course, Alzheimer's disease is one of the core collaboration topic we have been working on, but also on other machine learning topics. So, but I think this is, I mean, the first time, I do this discussion, I play this discussion role in a talk. I assume it is like a moderator and a panel. So I'm going to throw out some questions I prepared, and so Jiayu and I, perhaps we're going to discuss, but for others, feel free to chime in if you have comments or other questions. So I think first, since this is a reinforcement learning seminar series, and Jiayu presented our work on using reinforcement learning for, kind of like to build a chatbot to realize our goal is to do early MCI detection from hopefully the dialogues. I think one thing is, Jiayu, as you showed in that Lancet Neurology paper, like the different progression phase from the brain change to the cognition decline for Alzheimer's disease, and typically, the one of the limitation for the clinical approaches is when we identify them, it's already in a late stage. That's why we want to explore those other markers to hopefully to identify them early. This dialogue and conversation is definitely something really interesting. But like you presented, like our assumption is that when because we want to identify this early. So when there is some abnormalities when people talk, like they're talk differently than normal people, typically how early is that? In other words, I mean, this language marker, do they appear in a relatively early stage, or I mean, comparing to those like imaging or protein markers?
Oh, so that's a pretty good question. You basically saying, and I think for now, this current study, what we're trying to do is we're trying to, focus on this phase, right? So cognitive normal and MCI, right? So it's like early phase of MCI and cognitive normal. So that's basically the study. And then what comes with this is that if you look like this curve, so of course those are hypothetical models, right? So this kind of brain structure change way before any kind of symptom appears, right? And then so it's by symptoms that basically means this memory, short-term memory especially. So that kind of changes in the brain happen. They must come with some kind of changes in the behavior. So I guess that's what we can do, and then we can push. With this technology, what we can do is we can collect the early phase as much as possible. If we can get some kind of subjects on this phase, and we can really identify the disease like a couple of years before its onset. By onset, I mean going to the MCI, then we can have a lot of good things to do about the disease, and by developing new drugs and therapy for this, right? But yeah, so to answer your question, how early, and I think we're currently focusing on this tiny little region here, trying to find the boundary here, but we can do more than that with this technology, where we can push all the way to the place where the brain start to change, right? Even before anything happens, anything else.
Right.
Yeah.
Yeah, no, I mean that's very interesting, and I think that leads to my second question. I think a lot of the people may also have is because we are focusing on people. I mean, for patient progressing to AD at a specific stage. Although we do clinical trials to collect the dialogue sample or conversation samples, but I assume, like you said in your first part, the sample size, I don't know, it might be a challenge. For reinforcement learning as well. I mean, in our case, it is even more challenging because you can imagine, like Jiayu, you talk and I talk, we talk in different ways, right?
That's right. That's right.
There are a lot of individual variabilities. So I mean, our model now, I mean, performs on Heroku's data. It performs pretty well, but how much do you think it needs to do, or how long it needs? I mean, for going to really practical.
Okay, yeah. So that's a good question. I mean, basically, yes, we do talk differently, right? So people do talk differently, and that's why I think nowadays people are using a lot of ways to like normalize the conversation by using public data. Say for example, the MRI itself, it's one example, right? So you have different imaging from different people, but different people may have different, shape of the brain or things like that. And you have to normalize that into some kind of template before you can start to even analyzing them. So we can, by using some spirit, we can build this kind of references or template by public data, right? So we can, outside of the Alzheimer's, we have a lot of public conversation data available anywhere, everywhere. And we can use them to build some kind of standard template and trying to eliminate some kind of personal variation by building this template. And but we can use a template to strip off some kind of personal information as well. On the other hand, technology-wise, what we can do as well is, if we're trying to build an app, let's say for example, to patients, we can basically have this kind of personalized model as well. If the user using them for a while, we can actually normalize this personalized variability as well, right? So that may be wait till we deploy the system and we have this kind of personalized model on top of that.
Yeah, that's very interesting. I think that's also talks to a technical challenge about reinforcement learning in general, right? So how can you consider this individual variability when during your learning process? And
Yeah,
also I think, yeah, and also I think you pointed out the eye contact initiative you co-founded with Hiroko. I think that's a really good and important initiative to engage patients and also through the process. I mean, but you can like build better model. I think that's a really great move on this. And I think another thing maybe aside from Alzheimer's disease, but more from reinforcement learning. I mean, for myself, I mean. I do a lot of research on another type of data, which is electronic health records. And people in medicine nowadays, they have a general interest in reinforcement learning, of course, for obvious reasons, since
of course.
Google
Yeah.
wins, since Google wins, the Go game. And there are some, top-notch papers like MIT and Harvard. They published a paper on Nature Medicine where they are trying to use reinforcement learning to learn a treatment adjustment regime for patient in ICU suffer from sepsis, where they use reinforcement learning to adjust the dosage of intravenous fluid and vasopressor during the time. So essentially, because those two drugs, come with a combination, and you need to adjust the dosage based on your observation about the patient status. I mean, of course, the status captured by a bunch of lab tests, right? So, I mean, but I mean, there are other similar stuff in the clinics. Like, for example, there's another work from MIT where they try to use reinforcement learning to adjust the dosage of anesthesiology drug. And also I remember I also saw like some people from Stanford, they use still RL to adjust the dosage of some drug to treat VTE. I mean, but my concern, I think my concern for those kind of application is, like, for example, for adjustment drug dosage in treatment in critical care, it's a life-threatening scenario. So, like misadjustment or, some mistakes can cause very severe outcome. And plus, one of the technical challenge for those techniques is, for EHRs, electronic health records, you may not have enough data to do all the counterfactual inference to basically accurately get your estimation about the award. And essentially, there are lots of spaces in your action spaces, the decision passes, you really don't have the data to support your inference. So if there is a mistake on your guessing or estimation, it can lead to a really severe outcome. So that's why I like our scenario, like in this conversation space, where our goal was, of course, to have a low cost solution to for early detection of MCI, and it is serving as a screening tool. So essentially, if we say, this person is having problem, of course, further checkups is needed. So I don't know, Jiayu or any other guys in the Zoom. So if you have any thought about the appropriate or promising application scenarios of reinforcement learning in medicine in general.
Yeah, I can comment on this a few questions before the audience can, of course, the audience can jump in. But the thing is that, do we really expect, let's say for your case, and you're trying to use it, we have the states that's health, status inside of the body, and then trying to adjust the dosage and things like that. What we're trying to do here? Are we trying to simulate, what human experts are doing, or we're trying to explore a better way. Trying to use the dosage in a unique way that can maybe even outperform the performance of human. Right? So that's maybe one of the questions I have. For many of the reinforcement learning problems, we're trying to, we have this kind of exploration. We have to explore new strategies that hasn't been found before, right? So in order to beat people in Go game and all the kind of thing, you have to do better than human, right? And then you have to better than existing rules. But in medical, do we really have to do that, or we just trying to simulate human experts doing top of the notch, like doctors, they're doing this way, so I'm doing this way. So that's that's one of the philosophical questions, and what is the goal of this applying this reinforcement learning. And then of course from the historic data, what we can do is we can find out all kinds of correlation. And then it's hard to without intervention, it's hard to do like a causal analysis and things like that. But using the data, all we can do is something like this. We can build simulation. We can build very good simulation environments, and the reinforcement learning can actually learn how humans are doing, or even slightly better than that is possible. But I won't say it can do develop like a unique treatment to the way of using ventilation and combination of that dosage, and to have something stabilized. It's kind of hard to do that. I mean, without this kind of clinical trial, it's kind of hard to do that. But with the simulation, it can do at least as best and as human experts are doing. And then if you deploy some system in the production, it's more like trustworthy type of AI type of thing, where you really want your reinforcement learning policy don't deviate from some safe region, right? So let's say the reinforcement learning trying to say, hey, I'm trying to use like double the dosage, right? But never you never seen people do that before, and then you can't let the machine to decide to do that. So so that's my 5 cents on this topic. I don't know, it's like maybe Hong-Tu can actually comment on this.
Yeah, and in general, I think there's for reinforcement learning, if you really wanted to use the in medical science, this is, I think the one thing is going to, okay, it's happening, but I think it takes much longer. It takes time, and also depends on the subject areas. And there are some fields, some specific problems, and think that's it's not directly related to like treatment. Maybe faster, and for other things, this really depends on which stage you wanted to do. You want to do prevention, or doing diagnosis, or like treatment or prognosis. And I think that's the different, basically for these 4 different categories, maybe reinforcement learning may play different roles inside. And also this depends on how do you connect the data. I think given the current development of technologies, in particularly all kinds of the sensors and also these apps that people deployed, and I think for these different questions, I think I do think reinforcement learning may play critical roles inside. But I think this another set of questions. I think the reason I'm got interested in reinforcement, one thing is because for the tech companies, they have tons of data. You can easily kinds of updated policies, so that you can easily get a lot of kinds of feedback. And for the medical sciences, and we need to really find the which direction, so we can really use this to get some good result. I think I believe so, because you think about that, reinforcement learning is kinds of update and upgrade our kinds of policies, and in a kind of more efficient, effective way. Even in the older days, we're doing medical sciences, we still try to improve our policy all the times, right? And but it's at a different kinds of, even though from the concept perspective, people didn't mention that reinforcement learning, but actually they're doing that one, and kinds of implicitly. And so I think I do see a value of the reinforcement learning in medical science. and not just about the clinical trials and doing experiment designs, although what Jiayu did is, and I think there's a lot of more applications should be done, and I think that's the future for us.
Yeah, thank you. Thank you, Hongtu and Jiayu. I think those are really, really good points. And I think what Hongtu said is naturally brings to my next question. I think data is the most important, right? So like Jiayu, you also mentioned like federated learning. How can you, jointly learn from multiple different data sources in a privacy preserving way is one of your future direction. And federated learning, these kind of, privacy aware learning strategies is getting more and more popular in medicine recently as well. There's a paper on Nature Medicine, there's a paper on Nature Cover. I guess this availability of data is also like, I think, funding agencies like NIH is also aware of that, like their recent initiative like AIM Ahead, and also Bridge to AI, they emphasize contributing data and make it available after you're done with the project. They emphasize that a lot. But in the interim, also don't mention like precision medicine, these kind of things. But in the interim, the current situation is a lot of the times, for example, you're at the ethnic data, which you have a lot of detailed data about imaging genomics. On the other hand, like Jiayu, we have this dialogue data, and for example, we also have a large, clinical research network where large amount of electronic health record data is there. So we commonly see this kind of scenario, like we have different, I would say, disparate data sources where you have different patient cohort, and with each cohort, you capture different type of information because for the specific purpose, you construct that cohort. So in this case, of course, individual level linkage is a luxury. So, if you're lucky enough, you may be able to find some overlapping individuals participating in multiple studies. So that you have his or her multimodal information. But a lot of the times, the individuals, you wouldn't know who is who. Especially in medicine, we work on de-identified data. So, Jiayu, what do you think? Or, what's your perspective on what we can do in the current scenario? Like, we have these really disparate data sources. We have different samples and different features from machine learning language. So is there any possibility that we can somehow, join the efforts to jointly explore those disparate sources? Is there any promising, or even from reinforcement learning perspective, we can leverage those disparate data sources to boost the algorithm performance?
All right, thanks. So this is really a catch-up question for me, and we've been thinking about this for a while. I still recall one of the scenario we were trying to, asking for imaging data. I would say, hey, we have the imaging data, then I can give it to you. And they, okay, do you have more clinical information about that? And to say, if you need to connect to, let's say the medical records, right? It's going to be 10% of data for you. Say 10%? Yes, because many of them, they don't come with that kind of clinical information, right? So there's pretty common, like the more type of information that you want to include in your analysis, the less samples that you have, right? So this is pretty common. I'll say pretty common stuff. And there are a couple of ways where we can do that. One of them is that if there are possibilities for you to connect part of the data. Let's say 10% of the data is connected, and then the rest of 90% of data are not connected. And then if you want to use that kind of information, right, we don't want to waste the information, right? If we have 1,000 patients, from data from them, we don't want to use just the 100 of them. We want to use the total, right? So the thing is that we can build different models, and then we're trying to connect them we're trying to connect the different models through either doing the learning process or doing the data processing process. We can connect them, right? Say, for example, we can. This is a very intuitive example, right? So if we have, let's say 900 data points where we only have the imaging data, where we have another 100 patients where we have both the imaging and the clinical records, right? And then what we can do is we can build two models, right? And then we can require that the imaging part of them will share or some kind of joint training type of thing, so we can use as much information as possible in one learning setting. So that's something we can do. And then the other thing I think it's pretty much fall into your expertise is that even though sometimes we cannot directly connect to cohort, the thing is that we can use some kind of distributional differences, and we can anchor some of our most of our patients into one of those distributions, and trying to use what characterizes distribution as either a feature vector or representation to augment our learning process. So so even though we cannot align the entire data set we have, but still we can use distributional information to bias our learning. So that's something we can do at least, right? So yeah, that's what I have. Yeah, but maybe some of the other audience can jump in and give some insights on this as well.
Yeah, I just want to make that comments, but in generally, think about this way: you have a different data type. And imaging genetics, or even imaging, you have different the modalities. I know the genetics and the genomics, you have a different level of data. Also, you have this lifestyle data, and also you have EHR data set, right? These days, we try to connect all these kinds of nodes together in a certain way. I do agree with that. In these days, there's almost a few studies, really. Few studies really have all these data all simultaneously, or just for all the subjects. They have all these measurements. It's very hard to get that data set. To me, that the most important part is basically for each of these ages kind of relationship. If the data you have, at least for build data ages, is basically is unbiased. But in that case, I think that relationship we build is trustful. Is trustful. And in that case, you can finally just you can construct one age at a time and try to build at least initial kinds of information for that. And even though they may not share the same data number of subjects, that's one aspect. And another thing is, that these days people are using logic graph. We basically, for Alzheimer's disease, recently we built a logic graph for Alzheimer's disease. The reason is because there's a lot of different studies. We know that it's very biased. Is many studies published, but at least we can, connect all the dots together by searching around, right? But at the end of the day, you think about it, all these studies, all the information you have, you need to connect them and basically confirm as kind of logic graph for the physicians or for the researchers. I think that's my current solution for. I try to do it.
Yeah, I think Dr. Zhou was talking about basically we fuse the information using a knowledge graph or using a graph. And that's a data type, data level fusion, right? So I mentioned about, another type is like, during the learning type of fusion. Both, I think both can be, it's like complementary to each other. So, yeah. Fei, how do you think?
Yeah, no, that's I think great points. And actually, Jiayu, I mean, my group, we're building knowledge graph as well. I do think that's So
that's right. Yeah.
So we have a pretty big knowledge graph. I mean, but I do think that's definitely an important direction. So yeah, I think we are on top of 75 minutes. I think this very impressive presentation and also really interesting discussions. Hongzhu, so I don't know, should I hand over to you or?
Yeah, I think thank you. I think we ended this seminar today. I thank all these participants and the speakers for wonderful talks, and thank you guys. Have a nice day.
Yeah,
Bye.
thank you. Thank you. Take care. Bye. I guess.